What would you think if we told you that you are currently inside a black hole? These bizarre mass monsters are generally considered to be among the most unreal phenomena in the entire cosmos. But now, an analysis of observations made by the James Webb Telescope has suggested the spectacular conclusion that these gravitational monsters are much more hospitable to life than previously thought, and that our universe was actually born in the belly of one of these behemoths. But what exactly did Webb discover? Are we all really trapped in the heart of a black hole? And what do the new data mean for our overall understanding of the cosmos? Stay tuned until the end and join us in getting to the bottom of this gripping mystery. There are places where the world we know ceases to exist. Places where forces so extreme prevail that even space-time is distorted and which irretrievably swallow everything that comes too close to them. But what actually gives a black hole its elemental power? How can it be that the invisible nothingness plunges all structures in its vicinity into utter chaos? And does it even do that? Well, black holes are primarily known for one characteristic. They suck in everything that touches their event horizon. Once the cosmic death zone has been crossed, there is no escape, no matter, no information, not even light can pass from the inside to the outside of a black hole. This is simply due to the incomparable compactness of these surreal omnivores. Because their gigantic mass is concentrated in an extremely small volume, the gravitational pull in their vicinity is so strong that nothing can escape their grasp. To understand what this means in practice, consider the following example. A hypothetical black hole with the mass of the Sun would have an event horizon diameter of just 6 kilometers. As a reminder, the actual diameter of our parent star is around 1.4 million kilometers. Consequently, the case of the Earth would be even more insignificant. If the mass of a black hole were equal to that of our home planet, it would only be the size of a marble. But that's just theory.
In reality, these gravitational monsters have masses that test the limits of our imagination.
According to this, supermassive black holes can easily exceed the mass of our central star by millions or even billions. A quick look at 618 shows the absolute extremes the cosmos has already reached. Located in the constellation Canis Venati, this ludicrous thing weighs an estimated 66 billion solar masses. And we should not forget that the history of black hole research is still relatively young. After theoretical physicist John R. Carroll Wheeler coined the term in 1967, it was up to the experts to confirm the existence of these then still theoretical structures. Over time, researchers were able to observe the effects of these gravitational monsters on their surroundings many times. However, a very special milestone followed in 2019. Astronomers succeeded in photographing a black hole for the first time ever and were able to examine the appearance of these monsters in greater detail than ever before. The first photo of a black hole. This immediately raises the fundamental question of how this is even possible. In other words, how do you photograph something that is invisible in and of itself? After all, as we mentioned above, not even light can escape from such a cosmic prison. Fortunately, what applies to the actual black hole does not apply to the matter that falls into it. Rotating black holes are typically surrounded by a so-called accretion disk. In simple terms, this is the supply route for food. More precisely, the accretion disk encompasses the zone in which the incoming matter is accelerated and optically compressed due to the extreme gravitational forces. And as the matter rubs against each other in this brutal structure, it releases enormous amounts of energy, forming so-called jets that flow far beyond their parent galaxy into the intergalactic medium. Since the luminous disks around black holes stand out clearly against the dark background of space, experts were able to provide direct optical evidence of a gravitational monster for the first time in 2019 using the Event Horizon Telescope. And the fact that the ground-based network of radio telescopes is somewhat different from our cell phone cameras is demonstrated by the following. If our eyes were as powerful as the Event Horizon Telescope, we could even see the individual molecules in our hand. However, since this is not possible in practice, we should instead take a look at what the collected measurement data revealed in the active galactic core of Messier 87. The giant elliptical galaxy is located in the constellation Virgo, about 55 million light-years away from the Milky Way. And the groundbreaking image shows us the glowing shadow of the central supermassive black hole. In detail, the optical spectacle is the result of extremely strong light diffraction, and it shows us the moment just before it disappears inside the mass monster. The ring-shaped structure surrounding the black region in the center is the heated matter around the black hole, whose light is deflected and amplified by itself as if through a lens. Furthermore, direct observation also revealed some characteristics of the colossal gravitational trap. For example, the mass of the black hole was determined very accurately at 6.5 billion solar masses. Why black holes are not killing machines? But wait a minute. If black holes literally destroy everything and everyone around them, how can such a structure sit at the heart of a galaxy without tearing it apart? Wouldn't it have to completely shred its galactic surroundings? Well, not really. It's now even considered certain that virtually every galaxy center is adorned by a supermassive black hole and that these gravitational monsters play a fundamental role in galactic evolution. One thing we should not forget, outside the event horizon, black holes behave like any other massive body in space. And beyond the death zone, these bizarre giants can easily be orbited by other celestial bodies in stable orbits. And the Milky Way is no exception. The gigantic black hole hidden at the heart of our home galaxy is scientifically known as Sagittarius A star. And while it lies more than 26,000 light-years away from our host star and weighs around 4.15 million times the mass of the Sun, it should now also be captured on camera. More precisely, this happened in 2022 and was once again achieved with the help of the Event Horizon Telescope. Here too, we see a characteristic dark spot slumbering in the middle of an optical fireball. And while the image provided definitive proof that the object at the center of the Milky Way is indeed a black hole, the photo also gave researchers unprecedented insights into how black holes interact with their surroundings.
Is the universe inside a black hole?
However, there is still one central question that black holes inevitably raise. What is actually inside them? Well, the short answer is that we simply do not know for sure. According to classical physics, at the heart of these gravitational monsters is a so-called singularity, a point of infinite density where spacetime is infinitely curved and the known laws of nature fail. However, many scientists assume that this singularity does not represent a real physical state, but rather an indication that our theories are incomplete. In fact, instead of singularity, there could be a previously unknown quantum physical state, such as an extremely dense core, in which space and time lose their classical meaning. Approaches such as string theory or loop quantum gravity attempt to describe such states, but so far without complete success. Ultimately, however, what exactly happens behind the event horizon of a black hole cannot be directly observed since, as mentioned above, no information can escape from there. And so, it may be that the hidden world of these gravitational monsters will forever remain an astronomical mystery. Well, unless of course, we actually see the inside of black holes every day.
And let's be
clear, this assumption is not a highly speculative fringe theory. It's a seriously discussed conclusion derived from the latest observations of the JWST. But first things first, a team led by Luhr Shamir from Kansas State University evaluated over 260 early galaxies in the so-called JADES field which Webb had previously studied. And in the end, the experts were confronted with the astonishing fact that the majority of the galaxies rotate in the same direction. While around 2/3 of the observed structures rotate clockwise, only 1/3 rotate in the opposite direction. But why is this important? Well, it's quite simple. In a random universe, one would expect the rotational directions of galaxies to be evenly distributed. However, since this simply does not correspond to actual observations, explanations are needed. The first, admittedly not so spectacular, is based quite simply on measurement errors. To be precise, we may have fallen victim to the Doppler effect, which causes galaxies moving toward us to appear brighter than those moving away from us. This could lead to a distortion in the measurements, making more galaxies appear to be rotating in a certain direction than are actually present. The second much more exciting theory, however, suggests that the observations can be explained by a universe that originated in a black hole that already had its own rotation. According to experts, this idea is consistent with Schwartz cosmology, which postulates that our entire universe is the interior of a black hole in a larger mother universe. In this context, each black hole would form the gateway to a sub-universe or baby universe, while the rotation of the original black hole would influence the direction of rotation of the galaxies in the newly formed cosmos. However, the Webb data does not yet provide definitive proof for this scenario. But isn't it fascinating nonetheless? At the end of the day, it's possible that the answer to the agonizing question of what really lies inside black holes is simply us. And if you're wondering where the subscribe button is, the answer is simply here. Click on the subscribe and thumbs up button below our video to stay up to date from now on. We'll see you soon.